Hello, good morning, viewers. Welcome to this talk on energy conservation and energy audits for a green society. I am Professor Suresh Mane, working as principal at Girijabai Sale Institute of Technology in Karwar, Karnataka. So this talk is for AICTE online STTP, that is short-term training program, conducted by Malnad College of Engineering, Hassan, Department of Mechanical Engineering. So the contents of the presentation will be as follows. A lot of material is available, but I think I leave the presentation with the organizers. They can share it with you. But I'd like to touch upon the salient points so that we have a awareness about what is energy conservation, what is energy audits, and how we can conserve energy through energy audits. So we shall look at the Indian and global perspectives, basically through IEA, International Energy Agency, and British Petroleum. They have this global statistics. They come out with these annual reports. We shall also look at a steam power plant, basically where almost 60 to 65% of electricity generated in India or even globally comes through coal. We look at United Nations Environment Program, the emissions gap report, which has come only this month, December 2020, where you get the general idea, global idea basically. Even there is some report on India also. So we look at the Indian context. Indian electricity situation as on the 2020, we'll go through that. So there is a term called energy security, energy efficiency benefits, energy demand and supply in India, why we need energy conservation, what are the environmental implications, then energy intensity, then what are the sectors which consume major energy in India, potential for energy conservation in India, what are the barriers to energy conservation. Then there is the Energy Conservation Act of 2001. There is an examination for energy managers and energy auditors by Bureau of Energy Efficiency, Ministry of Power, Government of India. We'll just go through that. Graduate engineers will be interested to take up this test and qualify themselves as certified energy managers and auditors. We look at the emerging energy efficient technologies. Of course, now they are not only emerging, but they have become very popular. Then in academics, how we teach. I think some of you are from academics, so definitely we'll look into our academic approach towards EC, and then we'll see energy conservation in illumination, cooling. Illumination means lighting of buildings. We shall also look into cooling, then star rating of the products by B, and we shall look at the opportunities to save energy in boilers, steam system, furnaces, waste heat recovery, insulation motors, drives, pumps, compressors, DJ sets, etc. So regarding energy audit, regarding energy audit, uh, we shall look at why, where. We shall also look at types of energy audits, the various steps, then instruments used in audits. I think you will be interested to know the instruments. Then what are the energy efficient technologies? Then there is a B star labeling program. I think you have bought TV, fridge, fans, motors, pumps at home. They are all now labeled with star labeling from 1 to 5 stars. Air conditioners. Then some energy conservation tips for home. Then we'll look at some technologies like variable frequency drives, maximum demand controllers, automatic power factor controllers. Then lastly the references. So the content as such is taken from Bharat Petroleum, US Energy Information Administration, then UK you got DEFRA, Department of Environment, Food and Rural Affairs. You have CREDL, Karnataka Renewable Energy Development Limited, Central Electrical Authority for electricity basically, then MNRE, Ministry of New and Renewable Energy, then PCRA, Petroleum Conservation Research Association, and NPC, that is National Productivity Council. So before we start, I just want to ask you a question. What is sustainable development? Basically, world over, the human race today is aspiring for development, fast development, rapid development. But whether this development is sustainable. So, as engineers, I think in academics as well as industry, please let me know whether this development is sustainable. You can mention your comments in the comment section. Even your questions you can post in the comment section. I will definitely be happy to reply to them. Basically, sustainable development means it has got three aspects to it. Like it is like a triangle, three sides of a triangle. And for sustainable development, the first aspect is the economical aspect, which everybody is definitely aspiring for. Better standard of living, better revenue, better profits before tax, materialistic growth. This is all the economic part of it. But that alone is not enough. To form a triangle, you require three sides. So this is one side or one aspect of the sustainable development. There are another two sides to that. The second one is the environmental aspect. Please understand that man, in the quest for development, has taken this world for granted. Man thinks that the world belongs to him. Sorry, I don't agree with this. This world belongs to all living creatures, whether it is human beings, whether it is animals, it's birds, insects, marine life. So we all should live in harmony. And this environmental aspect therefore is very important, because today if you see, a lot of trees are being cut in the name of development, be it improvement of your roads especially. or converting this villages and towns into urban jungles, concrete jungles basically. And the third aspect is the societal aspect. So the development should bring harmony into the society and should not bring disharmony or unrest in the society. That is very important. So the sustainable development deals with environment as well as social aspect and not just the economic aspect of it. So United Nations they came out with this SDG Sustainable Development Goals in 2015. And I request you to please convey this forward because 5 years down the line still people are not aware of this sustainable development goals, and these goals are for entire world, not for any country specific. I'll read the 17 goals. So the sustainable development goals are the blueprint to achieve a better and more sustainable future for all. So please underline future for all it is. They address the global challenges we face, including poverty, inequality, climate change, environmental degradation, peace, and justice. So you can see here all the three aspects like poverty, inequality, this comes under economic aspect, climate change, environmental degradation, this comes under the environmental aspect, and peace and justice, that is a social aspect to that. So please learn more and take action. So we have got the 17 goals set by the United Nations, that is SDG, Sustainable Development Goals. Number 1 is no poverty. Then zero hunger, good health and well-being, quality education. See, we are into education, so quality of education is very important. That is fourth goal. Then gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequality, sustainable cities and communities, responsible consumption and production, climate change, life below water, life on land, peace and justice, strong institutions, partnership to achieve the goal. So you have got 17, but I think 4 are relevant to our talk, like clean water and sanitation, affordable and clean energy, sustainable cities and communities, and climate action. They have something to do with energy and energy conservation. International Energy Agency IEA, they have a document called World Energy Outlook, that is an annual report basically. 2019, I have just gone through that. It says the energy world is marked by a series of deep disparities. The gap between the promise of energy for all and the fact that almost 1 billion people still do not have access to electricity. World has a population of 7.5 billion, that is 750 crores, and in that almost 100 crores, 1 billion, still do not have access to electricity. This is a fact. Please let us go by data and let us not go by opinions. I request you. Everybody has opinion, but we should always go by data. So these are all global data and authentic data. You can go through the websites also available online. So this is a deep disparity. In some countries they are using lot of energy and some countries are deprived of energy. Also, this World Environmental Report, which came, that shows the energy related emissions were highest in 2018. Luckily, due to Corona this year, the emissions are reduced. And mostly these emissions are because of fossil fuel burning, whether it is solid coal or oil or even gas. Now coming to India, that World Energy Outlook by IEA, International Energy Agency. India, the energy demand is growing rapidly because of higher aspirations, higher standard of living, economic development, and even growth in the population. Government of India has made remarkable progress in providing access to electricity and clean cooking while implementing the range of energy market reforms and integrating a high share of renewable energy sources into the grid. I think you might have seen now a lot of windmills are available. Extensively, India aggressively has gone for windmills and this clean cooking for rural masses. Earlier, they were using this wood, so they have been provided with LPG connection, and even electricity is trying to be supplied to villages also. So, lot of efforts have been made by India, and it is being appreciated globally. Again, in terms of statistics, if India has gone for energy efficiency measures, like you just spoke of star labeling, there are another many approaches for industry as well as um, agriculture and commerce. So, energy efficiency increase have enabled the avoidance of an additional 15% of the energy demand and 300 million tons of CO2 emissions over the period 2000 to 2018. So, because of the energy efficiency measures what India has taken, so almost 15% of energy demand has been avoided. Uh, I think we are all engineers and we have studied all thermodynamics and all such stuff in our college days. But the simple thumb rule is 1 unit what we consume today. If you avoid that, reduce it, then it is like avoiding 2 units of energy generation. Because the efficiency of the equipment what we use is less, there are a lot of T and D losses, that is transmission and distribution losses, and even the power generation itself is not more efficient than 40%. And in combined cycle, it can go up to 60%. So again, coming to the progress, in government of India is continuing to focus on providing secure, affordable, and sustainable energy. It is a good initiative. A lot of urbanization is taking place in this country. Means the people are moving from villages to cities, and hence the demand for electricity and other energy is growing. Similarly, we have got this British Petroleum Energy Outlook 2019. I think I have given the link here. So, dear friends, can you tell me what is the level of carbon dioxide in atmosphere now, roughly, and what it was around 50 years back? Please type your responses so that we understand that you are all actively participating in this discussion. So, what is the CO2 level today, and what was the CO2 level at during independence 75 years ago? And who is responsible? Secondly, who is responsible for this increase in CO2 levels? Whether it is animals, birds, uh, marine life ecosystem, or we, the human beings. Please you can for further details regarding this uh, World Energy Outlook or Energy Outlook by British Petroleum, you can click onto this link, and PDFs are available online. So one more document which has been released by United Nations Environmental Program only this month in December 2020 is the Emissions Gap Report, EGR. And now they say that the global emissions, greenhouse gases, they continue to rise in 2019, and total emissions are almost 59 gigaton CO2 equivalent. Please understand, it's a huge number and it is rising. That is a matter of concern. And fossil fuels CO2 emissions, they almost contribute 65%, two-third. And past 10 years, since 2010, these green gas emissions are rising annually at the rate of 1.3%. So this is a annual increase. And China, South Africa, European Union, and India, they alone constitute 55%. So these are the huge contributions. So this COVID pandemic, only a brief dip, short time it is. But the Paris Agreement goals wants the global warming to be well below 2%, 2 degrees centigrade rise, and should pursue 1.5 degrees centigrade rise. But actually, with the rate we are going, it will go almost 3 degrees centigrade rise. So we need to cut almost 25% of the GHG emissions in 2030. And it depends on our lifestyle, aviation, and shipping sector to bridge the gap. And now people are talking of net zero emission pledges. So net zero emissions also we shall see. So now coming to the global greenhouse gas emissions, what are the contributors? You can see the graph from 1990, almost 30 years graph it is. You can see the growth, like 1.3%, whatever I was told, it is growing. And it was almost less than 40, and today it is almost reaching 60 gigatons per year. CO2 equivalent, because you can see that orange color, that is fossil CO2, 65%, and that share is almost there for all these years. Then you have got blue color is methane, next greenhouse gas. Then third is N2O in the red. Then this fluorinated gases, basically your CFCs, chlorofluorocarbon, what you call, fluorine gas. Then this sky blue and all, that is land use change. But you can see from this graph that majority is basically because of fossil fuel CO2, that is we are burning petrol, diesel, coal as well as natural gas. Now just see the one more graph you can see. These all graphs are taken from that EGR, that is the Environmental Gap Report of United Nations. You can see that in case you want to go for 2 degrees centigrade rise, we have to drastically reduce the energy requirement. So you have got 3 lines: blue, current energy policy, then unconditional NDC scenario, and then the red one is conditional. So these are the national contributions what the countries have agreed. And from 60 almost it has to come down. You please see the sketch. So it is a Herculean task. That is why most of the countries have gone for renewable energy. And just to show the disparity, you can see how huge is the disparity. You can see the left graph, bar graph, where top 1% of the population, their per capita carbon emissions in 2015, that is again in terms of CO2, you can just see is almost 75. Whereas the bottom 50% is very low. And the global average is 2.1 tons. The India is almost half of this. The global average is 2.1 ton CO2. This should be the target for next 10 years, 2030, for 1.5 degree centigrade rise in temperature. So these graphs, you please understand that the top people, I think we all come under this top 1% income earners who have all these facilities of a car, bike, AC. So we need to look into this red bar graph. So that is very bad. You can see the country-wise emissions also over the last 30 years, how it is growing. And you can see India. India now is almost 1/4. So in this greenhouse gas emissions, but the per capita consumption is low. You can see the right side graph. The orange color line is the lowest. Other countries like USA, Russia, they are on the higher side. So as I was telling, that the rich people, or like top 1% people, they are consuming, and you can see the red graph, bar graph. So the onus is on these people to reduce the consumption. You can see almost in the right side, the pie chart, that 1% of the population, again in the red color it is shown, 1% of the population, they consume almost 15% of the emissions. So that is very bad. So you can see the country-wise emissions. India is standing fourth, but per capita consumption, this is orange color line you can see. Left graph and right graph, the per capita consumption is less. So there is one organization called German Watch, and I think last week they have come out with a report. Climate Change Performance Index, CCPI they call it. And they say that India is a top performer. We are happy to share this on climate mitigation, but still more needs to be done. So as per the Paris Agreement of 2015, when this SDGs, where Sustainable Development Goals were given, countries are not doing enough. United States as such is the worst performer with a rank of 61. And India is in the top 10 actually. Very happy to share this. Now let us come to this. I think we have seen all through that 65% of the electricity produced is through thermal route, that is coal based power plant. So this is one small sketch I had taken from this energy education. You require water, you require coal to produce electricity. Again we can see that coal is mainly used by for electricity generation in India. This is again Ministry of Coal, Central Statistic Office data. So I would like to ask you one more question now here. Burning 1 kg of coal leads to how much of CO2 emissions? And 1 kg of coal will give how much of electricity? Have you any idea of this? Please let me know. Now, if you want the answer, I can just because the answers vary depending on the technology used, and it's almost like 1 kg of burning coal will give almost 0.8 kg of carbon dioxide. And 0.8 kg of coal is used for generating 1 unit of electricity. So coming to your house, now we all stay in houses. So I think you might have seen the electricity bill. Please write in the comment section what is your consumption of electricity per month. Then I think if you divide it by number of people, you can come to the per capita consumption. So then you will understand that you are coming in that 1% bracket, what that red bar I had shown in the previous charts. So to discourage that only, if you look at your electricity bills, it is not a uniform tariff. The tariff varies from for different slabs, like 0 to 100 it is low, then 100 to 200 it is slightly high, and then 200 to 300 it increases, and as the slab increases the tariff increases. I hope you have seen that. That is to discourage high consumption. And I think the bill has got various components. I don't know whether you have seen that. You please see, there is something called fixed charges, and there is a penalty for low power factor. Then there is something called banking and wheeling charges, fuel surcharges, and interest. So I would like all of you to draw a chart, pie chart, means you divide what is the energy sources you are using at home, basically. Means totally, as an individual, as a person, you use energy. Right from early morning, you get up, you switch on the light. You may switch on the fan. You switch on the geyser. Then you cook food, or a family cooks food. Then you travel to office, whatever mode it is. So you are spending a lot of money for all this energy, and the growth of human beings is basically attributed to the growth of energy sector. So you please let me know what are the sources of energy you are using, so that you will understand. You can write in the comment box what are the energy sources you are using, and then again, of course, you can make out the per capita consumption also, so that you can think. As we progress in this discussion, you can think on ways to reduce that. So of late there is a concept of green buildings. I don't know whether you heard of this, but mechanical engineers are also involved into that. A green building is that building in its design, construction, or operation reduces or eliminates negative impacts on our climate and natural environment. So green building, now we come into this operation basically. Means we should reduce the negative impacts on the climate change and the environment during operation, because the design and construction is taken care by architects and civil engineers. And in operation you have this heating, ventilation, air conditioning systems, hot water systems. Okay, these all come under operation, and mechanical engineers, they deal with this equipment. So lot of material is there on green buildings. You can just Google it out. Lot of ratings are given, certification is given, like Griha is there, then LEED is there. There are many organizations, 4 organizations I know in India which give the certification for green buildings. Then one more concept is that ECBC, Energy Conservation Building Code. It has come up in 2007, but again amended in 2017 after 10 years. And that is being implemented now in many states like Andhra Pradesh, Goa and all. Now it is a mandatory, this is not optional. That green building certification is optional, but this ACBC is mandatory and is implemented by the state governments. So I think this also you can just go through. Here also again, as I said, like water heating, pumping, air conditioning, these all come under the mechanical engineers domain. If you look at the electricity consumption in India, I think this is an old figure, you can just see what I have downloaded. Basically, why I was talking about this building, Energy Conservation Building Code, ECBC, because buildings, they themselves consume 33% of the electricity, you can see. So that is why it is very important that we take care of buildings. Industry consumes almost 42%, agriculture 70%. I am talking about electricity here, and that is why this ECBC has come into force. So we are trying to reduce in industry also a lot of initiatives are there by Bureau of Energy Efficiency, and in buildings they come out, secondly they have come out with buildings, that is ECBC. I think you all know that fossil fuels are finite in nature. We found them some 200 years back, and another 200 years maximum, coal, oil, gas, all will be depleted. So this graph shows that fossil fuels, we found them and it got exhausted. So this is right from 100 BC to 4000 AD. So earlier it was not there, only some 200 years back we found, and I think another 100 or 200 years it will all be over. So we are interested in economic growth, where we want high GDP, but fossil fuels are used. And can you tell me what are the reserves of oil and gas in India? Or how long they are going to last, Indian coal, oil and gas? Please write down in the comment box, and you should have a fair idea. And do you know last year, like how much India has spent, how much foreign exchange was spent for importing of crude oil? Just a guess, annual guess or even per day, if you can guess. The figure is mind-boggling actually, a very huge figure. Please write in the comment box so that we will understand. You will appreciate that how much India spends. Almost more than 2000 crores India spends per day, and on an annual basis it is 7,50,000 crores of oil import bill, a huge amount. And this amount can be used for education, healthcare. I hope you understand. Then Indian electrical situation, the thermal share is almost 80%, renewable is now almost 20%. But still we are having deficit. These power cuts, whatever you see, these power cuts in cities and villages, it is more rampant. That is a clear indication of deficit. Mostly due to deficit only it has been cut. Now let us come to energy security aspect. Like India is not energy independent nation. Okay, so it is there are issues with energy security because energy is imported. India, whatever you see, it has got a lot of security concerns because a lot of oil, this crude, we just seen almost 7,50,000 crores or 2,000 crores per day, the imports. So it comes through the sea route, and in case of any war, or any problems with neighbors, we may land in problem. That is why one of the reason India is going for all electrical vehicles. I think you might have seen lot of focus is given on electrical vehicles. Even trains now we are running, we are going for electrical engines, locomotives, so that we reduce our dependence on imported oil, because we are vulnerable to the fluctuations in the global market, and that is why in India we have gone for demand side management, DSM. So we are trying to reduce our demand, and even as I said, India has taken a very bold decision of going for electrification of transport, whether it is public transport, private transport, or even railways for that matter. So what are the benefits of energy efficiency? If you look at like you have reduced bills, increased competitiveness, increased productivity for industry, and globally reduction in greenhouse gases and other emissions, maintains a sustainable environment, and for the nation as such, reduced energy imports. So this avoided cost can be used for poverty alleviation, conservation of limited resources, and energy security. So if you look at Indian scenario, if you look at Indian scenario, you can see that 80% of the oil used for transport is imported. Whatever this oil, petrol and diesel we are using is almost imported. 20% is only our Indian share. And there is a shortage both in peak as well as regular power, and lot of investment. I think you are all aware that for 1 megawatt you require almost 5 crores of investment. A huge capital investment is required, and per capita energy electricity consumption in India is almost 1120 units per annum. Means one person uses 1120 units per annum. So you divide it by 12, so it is almost like 100 units, less than 100 units. Now you just see in your own house how much per capita consumption you are doing. So you will understand that I am very sure most of us are consuming more than this national average. Okay. If you are consuming 100 units, suppose there are 4 people in the house and they are consuming 400 units, that is 100 units per head. That is more than the national average, because national average is 1120 and yours will become 1200. Now the question comes, why energy conservation? So you can see imported sources of energy, foreign currency is being lost, energy security is at stake, pollution. Okay. And a lot of villages are still, we have seen 1 billion people globally are yet to get electricity, and we are almost producing 2194 million tons of CO2 greenhouse gas emissions in 2018. So you can see for any industry, like you have a very simple diagram basically. It shows the inputs. Left side you have got the inputs like energy, water, chemicals, raw material, and right side you have got the product. But you see what is going on the top and bottom. Top you have got the emissions from combustions and emissions from the process, and bottom you can see solid waste, liquid waste. Environmental concerns are there: ozone layer depletion, global warming. So as I was telling, one unit power saved is almost 1.1 kg of CO2 avoided by thermal power plants. So greenhouse gas effect, in simple terms, the temperature of earth is increasing, the temperature of atmosphere is increasing because of this greenhouse gases. Acid rain, again, Taj Mahal and all, due to this emissions which go in the form of oxides of sulfur and oxides of nitrogen, you can see SO2, NOx. These mix with water vapor in the clouds and they form as weak acids. So they are dangerous. Then ozone layer depletion, all this CFC, this chlorofluorocarbons and all. I was told one molecule of chlorine will destroy almost 1 lakh molecules of ozone in its lifetime. So we are reducing this CFCs in our refrigerators, air conditioners. And this ozone is in the stratosphere, basically around 25 kilometers above, you can see. And there we have sent the research balloons to study the thickness is measured in terms of Dobson units. Just one few statistics about India again to reiterate. You can see coal around 2 lakh megawatt, gas 25,000 megawatt. So ultimately it is 61% thermal. So these are all sources from Ministry of Power. Then India, the generation is 1252 billion units. The plant load factor is 56%. And we still have 6,500 million units of deficit. So the only option is renewables, and India is heavily going for this renewables. Like wind is there, solar is there, biomass, small hydro basically. And then one more term I think I would like to say, there is something called energy intensity. Simple energy intensity means energy intensity of India per unit of GDP. This is higher by almost 3.7 times of Japan, 1.4 times of Asia, and 1.5 times of USA. Now what it indicates means, suppose you are making coal, we are making steel, we are using coal. Okay, so whatever manufacturing process is there, we are making cement, we are using lot of energy. So this major energy consuming industries, they are consuming a lot of energy because the technology is not in par with the global standards. One is the technology and second is the operation and maintenance. Considering this, we can see we are almost 1.5 times of Asia and USA and almost 3.7 times of Japan. So they are more energy efficient when compared to India. Now coming to again this sector, we have seen industry 41-43%, residential. So these figures vary slightly based on year and as well as various agencies. So we have seen one more question I would like to pose here. Can you tell me what are the T and D losses, transmission and distribution losses? Suppose 100 units of electricity is generated in Raichur thermal power plant or Ballari thermal power plant and it is supplied. How much exactly you get? Can you tell me? Please write in the comment section so that you will appreciate as an engineer or as a common man also, you will understand that almost 20% in Karnataka is lost to transmission and distribution. So electricity is lost in the form of heat actually. As engineers, you know that energy can neither be created nor destroyed. It changes form. So it gets converted into heat. And today India has got a private sector share of almost 46% in power generation. So what is the potential of saving energy? This all discussion what we are doing is basically to save energy, and it is almost 23% if you look at, and 20% in domestic and transport industry, 25%. So this is a huge number. Please understand, this is a huge number. It may look small to you. I can give some two examples, like we all use TV at home. We use mobile chargers, laptops, and all, But most of us, overnight we will keep the TV in that. We will put it off by remote. The almost 8 watts of electricity is consumed. Uh, and just imagine how many TVs are there in India. I think more than 30 crores. So this, when you take off these families, when you consider this, then it becomes a very big number. Individually, it may look very small. 8 watts per hour, almost 24 hours is 200 watts. 200 watts is almost in 5 days it is 1 unit. So 30 days it is 5 units. So 5 units for one family, for one TV. 5 units into 30 crores is almost 150 crores units wasted unnecessarily. So please understand, it is a very big number, because we are talking about 35 crore families. So we can say almost 35,000 megawatts of energy, and 1 unit saved avoids 2.5 to 3 times of fresh capacity addition. As I said, the transmission distribution losses are there. Even the power generation is almost 40% efficient only. Considering this, if you save 1 unit of electricity in your house, you are almost avoiding 3 units of capacity addition. That is a very big number. So we are talking about energy intensity. Again, we will come here, like specific energy use. So whenever in the major industries like cement, steel, paper and pulp, fertilizers, we can reduce it to the international levels, because our intensity is high. So we need to improve our technologies to the global standards. So what are the barriers? We will see the barriers to energy efficiency. The lack of awareness. This was my part of my research also. The lack of awareness is a lack of education and training. So I thought I'll share some information with you on this. Economic and market distortions are there. Lack of standardization and labeling. I think now this label B has taken up labels. Earlier it was voluntary, but now most of the equipments are mandatory, and some are voluntary, but in due course everything will become mandatory. And this standards and labeling also, they are improving the efficiency. It is not that 5-star rating what was there 5 years ago, the same specific energy will be there for this year also. No, it is improving. So that is also there. Lack of financing and lack of coordination. Even your coordination means you can take your own house only. There will be a lot of coordination problems in your own house. You can see the way LPG is used, you can see electricity used, you will have difference of opinion in your family itself. Okay, so that problem I will just give about family, because at national level also, different states also, different industries, you have this problem. So Government of India enacted this Energy Conservation Act in 2001, and they come out with a BEE, Bureau of Energy Efficiency, under the Ministry of Power. So they have got standards and labeling program. Then they come out with the minimum energy consumption performance standards. So they prohibit manufacture of components and equipments which do not comply with these standards. Now, as I said, agriculture pumps, distribution transformers, motors, lighting products, AC, fans, all have been given this standards. Like you have got star rating, I will show you this in subsequent slides. Then we had just discussed about building codes, ECBC. So I think this has changed. 500 kilowatt and above, if it is there in a new commercial complex and all, then they come under this ECBC. And there is energy conservation fund also, so which is used for awareness, innovation, innovative financing, R&D testing, and this Bureau of Energy Efficiency is the agency of the Government of India and the Ministry of Power, created in March 2002 under the provisions of Nation's Energy Conservation Act. The agency functions is to develop programs which will increase the conservation and efficient use of energy in India. So I was just trying to tell you, there is an exam, beautiful exam conducted by this Bureau of Energy Efficiency for Certified Energy Manager and Certified Energy Auditor. So it is conducted annually, and 10,000 is the fees. If you write on your own, if your company sponsors, I think it's 20,000 rupees. There are 3 papers. If you pass the 3 papers, you become energy manager. There is one more paper, that is open book exam, and if you write that exam and pass, you become a auditor. Textbooks are available. They are online available. You can download PDF copies. Beautiful books. I am very happy to say that I am a certified energy auditor and manager also. And lot of information you get from these books. So please, I sincerely suggest you to download these books and read them. And this exam is conducted by NPC, that is National Productivity Council, Ambedkar Institute of Productivity, that is at Chennai. So this was about the examination. So now let us look at some designated consumers are there actually. As per the Energy Conservation Act, because now the government has to focus on the big industries, not the small. As if you see the pie chart, even I told you to make a pie chart of your house energy consumption, like where you spend more. Suppose you are spending some 10,000 rupees for petrol of your cars, then 4,000 rupees for LPG, 2,000 rupees for electricity per month. Then first you will have to focus on the high, that is 10,000 rupees for your car petrol. Then based on the percentage share, you will focus. Accordingly, here also government has made some designated consumers so that they can bring efficiency in. They like cement factories, sugar factories, steel. These are all coming under the designated consumers, and so they have to have compulsory have energy managers in their units, and energy audit has to be conducted annually. I think this will be of some interest to you. This emerging energy environment technologies like maximum demand controllers. The electrical thing, like you have demand for your college. I don't know whether you are aware. Every college and every factory, they have got some contract demand. So whatever is the contract demand, if you exceed that contract demand, then there will be penalty. So to reduce that, there is something called MD control, maximum demand control. Then power factor also similarly. If the power factor is less than 0.9, there will be penalty. So different states, different discoms, they have got different. Then means we have to improve the power factor, and that is why a lot of capacitors are used basically. Then energy efficient motors are there now. I think motors are almost 93% efficient. Today's motors are very highly efficient with good bearings, good machining, good high quality copper used. And this distribution transformer also they are coming to the low load losses. They are dry type. All you have seen is oil type, na liquid, oil cooled. But now dry type transformers are there. Even inverters, welding. The old you have seen the big transformers are used, but now today they are now more used. Now for all production activities in industries, inverters are used. I think you might have seen this inverter, small units. And this inverter technology is used everywhere. I think you might have seen in your lifts, uh, inverter AC. Everywhere this technology is coming up because it saves a lot of electricity. And for illumination, I think you need to go for daylighting, natural daylighting. This we have discussed. So this is the progress of this Bureau of Energy Efficiency. Like I said, energy intensive industries, how they have done, what all, like energy management cell, small group activities, lot of monitoring, targeting is being done, targets are being set. So now as a faculties in mechanical engineering, we teach subjects like applied thermodynamics, we teach about engines, IC engines, we teach about air conditioner systems. But are we aware what is the specific steam rate or steam consumption for power plant, coal-based power plant? Like to produce 1 unit of electricity, how much coal is used or how much steam is used? Then even in IC engines, we teach all air standard efficiency. uh, we teach about all this auto cycle, diesel cycle, dual cycles and all. But whether we know what is the SFC, specific fuel consumption, even if you look at when you go out and in the market you have that sugarcane juice, that small engine also they have put, if you go through the label clearly, you will find that small engines, they almost have got around 500 grams of fuel they consume per kilowatt hour. Whereas big engines like train engines and all, they consume almost 200 grams of diesel per kilowatt hour. So you can just see the disparity in the specific fuel consumption. Similarly, the air conditioners. Now earlier we used to call COP, coefficient of performance. Now it's something called energy efficiency ratio. So how efficient is your AC? One is star rating is there definitely, but as an engineer you should know also the year. So whether we are teaching this, but I think this is missing from our teaching. We teach all theoretical aspects and we do not connect with the students with the real life conditions. So but these are all real life. When you go to industry, in a power plant, you ask him, he'll tell you what is the SSR, steel specific steam rate. He'll tell you the fuel consumption, SFC. So Karnataka scenario is this. They have got an organization called CREDL, Karnataka Renewable Energy Development Limited. So Karnataka itself has got almost 1 crore, you can see, power connections. This is a old figure. Now the question comes, what we can do. So this should be our takeaway. We need to educate our family members, friends. All that bulbs, old technology bulbs, we need to replace them with LEDs. Now all LEDs have come. And even fan regulators, that big regulators were there. You can change with electronic regulators. And now there is slim tube lights have come, LED tube lights have come. Houses should be painted white, ceiling and walls, or even light color, so that a lot of light will be reflected. Switch off gadgets when not required. I told you about the TV, keeping in standby. Don't keep the TV in standby mode. Switch off. You will save. And please understand, every drop, every unit counts. So when planning for house also, you should allow for a lot of natural daylighting. You should take advantage of light. So during daytime you should not use light actually. As simple as that. Only when the sunset is there you should put on the lights. So that kind of design should be there. And should not use electricity or LPG for heating water. Please go for solar water heaters. And you should have controls, the automatic thermostatic controls for water heaters, AC, refrigerators. They should be in working order. So illumination, I think you know all LED lights. Then task lighting, wherever you are working, only that area should be lighted, not the entire hall or entire room. Then there are a lot of points are there. You can just go through this. Like this is a efficiency. You can see incandescent bulbs. They are producing only on an average 14 watts lumens per watt. Means the efficiency is only 14 lumens per watt. They are giving 14 lumens of light output for every watt of power consumed. Whereas LEDs, if you look, they are very high, almost 60, 80 lumens per watt. And even the life is high. That is why now everywhere people are switching on to LEDs. Then let us look at home cooling. The 50% of the heat which enters our house now, it enters through our roof. And basically this glass, you see this all big glass buildings now. Nowadays the fashion like structural glazing is picking up everywhere. Even earlier it was in commercial buildings, office buildings, but now even for houses, lot of glass is. Please understand, this glass will allow lot of heat inside the building. It will increase your heat load. So because of that, you will use the fan more or you will use the AC more. Okay. So the single glass whatever you used is not good. You can go for double glazing, two glasses with with some inert gas in between, so that double glazing is picking up now. It is costly, around twice the cost of the single glass, but it will save you a lot of heat ingress into the building. So especially larger the windows to wall ratio, they call it W. So you should reduce. You require windows only for lighting, but not you should not allow heat inside. And roof also, a lot of insulation is taking place in the roofs. You can have roof gardens or puff insulation, extended polystyrene insulation on the roofs or even ceiling. So these are again some measures. You can plant trees around the house, especially in the south and the west side where you get lot of heat. The heat, that is why I think you see in all the solar water heaters, water placed, they are placed on the south side, so that heat ingress into the house is reduced. South and west you get lot of heat. Then the AC now, because of corona and all, now AC you should put at 26, 27 degrees only. Earlier people used to keep at 18 degrees. Now it is advisable to keep at 27 to 30 degrees, no issues. And clean the air filters regularly. Regarding industrial applications, I think some of you are from industry, have exposure to industry. I tell you, give examples. Equipment oversize, that is very common. What is equipment oversize? I will tell you. Like suppose we are having a fridge at home, or we are having AC at home. What we do? We always buy big fridge, a big AC. Instead of the requirement will be 100 liters, we will buy 200 liter fridge. AC we require 1 ton, we will buy 2 ton AC, because we will see further. Because we are growing, we are all growing, families are growing, and incomes are growing. So definitely we go for higher size. Similarly in industry also. Lot of equipment, whatever equipment you are using, there will be oversizing. So that has to be taken care of. Very important it is. Then mostly when you use oversized equipments, then you will be operating at part load. When part load you will operate, the efficiency is low. Full load efficiency is high, but part load efficiency of any equipment for that matter is low. And go for star rating, and especially minimum 3 star and you got 5 star rating equipments also. So go for this star rating. So then there is something called BMS, building monitoring system. Softwares are available now. And I was just reading, I think now you have got like Eco Samhita even for your houses. In every house you will get a star rating for your house also. How energy efficient your house is. Single star to 5 star. This kind of rating they are going to give for houses, individual houses also. Shortly, it is coming up. Then there is something called time of day metering. This power plants, the load of the power plant, it varies. The demand of electricity varies depending on the time. So especially in the night from 11 to 5, it is very low. That is why some companies are offering discount. If you use the electricity between 11 p.m. to 5 p.m., something nearby that, you get discount of 10 to 15%. So not what people do, especially I have seen in dairy industry. So they will use a lot of electricity during that time for ice making, for cooling of water and all. Then use of renewables, waste heat recovery, lot of heat. See, waste, as a mechanical engineer, whatever heat is rejected from your bike, car, industry, that is waste, and that heat has not come free. We have paid for the fuel. So we will try to extract the maximum amount of heat, and that is why I think in if you take a power plant, steam power plant, you have got something called economizer, you have got air preheaters. So all these things are using the waste heat to heat the water or air. Industry, I think you have got motors, the energy efficient motors, energy efficient transformers, energy efficient pumps. All these new technologies have come. So lot of data is available on energy conservation in boilers. Now let us look at boilers. So here also one common technology is VFD. We will discuss about that in the next slides. Variable frequency drives. So because this all boilers and require a lot of air for burning, and this air is supplied by the fans, and if we have, I have seen this very huge fans in industry especially. Lot of other this technologies are shown here. Like one technology is oxygen level. We teach like applied thermodynamics and all we teach, na. So here there is in real life what they do, they see the oxygen in the exhaust gas, that should be low. If you are using more, if the more amount of oxygen is there in the exhaust gas, then we are supplying more air than required. If we are supplying more air than required, then this air is carrying that heat away. So that is also not good. Less amount of oxygen is also not good because we are not burning the entire fuel. More amount of oxygen is also not good because we are sending lot of heat away in the form of hot air. So a trade-off is there, and almost 10% or below only should be the amount of oxygen in the exhaust gas. So these are few technologies I think you will appreciate. You can go through this. A lot of technologies are there. So we are also discussing about part load characteristics. So we should reduce part load. Any equipment, you should always go for full load. And even for your college, if you just look at, I don't know whether you have seen, instead of having in your college one big generator for entire all the college, now people have gone for like small generator for each department. So those each generator, when the power cut is there, then it will take care of the requirement of the department. Because if you have big one, it will not be running at full load, it will be running at part load. Then part load efficiency are low. We also teach applied thermodynamics. I think we teach all like this, like the concepts we teach basically. like gas turbine with the reheaters, then gas turbine with intercooler, then combined technology like there. In real life, you will have something like this. You will have intercooler, you will have reheater as well as regenerator. In real life, you will have all three. It is not that one. So this is what you will have in real life. Then I was telling like in steam power plant you have got economizer, air preheater, ESP. ESP is electrostatic precipitator. When the exhaust gas is going, all the dust that will be caught in this ESP. Then there is FGD unit. Actually, this also they have made it mandatory. The sulfur dioxide which is going in this emission exhaust this is called as flue gas desulfurization unit. So this is a very, very important unit, so that you remove the sulfur dioxide, because that sulfur that is very dangerous. It causes that acid rain, one thing, and second thing, if that sulfur gets condensed in the in your exhaust system only, all that chimney and all they will get corroded. Then we are using that field water heater, regeneration, reheating technologies. So even the steam system in industries, if you see, there are a lot of steam systems where steam is used actually in industry in water. If you look at your house, milk we are heating in a small vessel, because but if you look at industry like dairy industry, I have visited dairies in Dharwad, Belgaum and all. There in dairy, steam is used for heating. Mostly in most of the industries, steam is used for heating. So these are all some tips about lot of technologies are there. I don't want to explain all these technologies. You can go through this. Similarly, you got furnaces for heating, like heat treatment and all. You have got a lot of furnaces. Here also, that I told you that oxygen, monitoring of oxygen in the excess air. They are very important technology. Please understand. From real life perspective, I am telling. And even this air curtains, like wherever you use air conditioning, AC buildings and all, railway reservation office and all you have seen. So there will be air curtains, so that the hot air doesn't get inside. So similarly here, the cold air does not get inside. You got air curtains for furnaces also. A lot of everything you can see. The insulation, now ceramic insulation has come. The burner design has been improved. Then loading, as I said, load it to the full capacity. Then heat recovery device. All these things are coming in. And even see, one thing is, the flame should not touch the stock. It should be away. Then only it gives the maximum amount of heat. Then a lot of waste heat recoveries are taking place, and that is why we see now absorption refrigeration. Earlier we were only talking about vapor compression refrigeration system, but today wherever you have waste heat, definitely you can go for a vapor absorption refrigeration system. They are for a huge capacity, say 100 tons, 1000 tons and all. Even insulation, I think we teach a heat transfer, a lot of insulation we teach, what is critical thickness of insulation and all. But in real life, you can see there are different technologies used. Energy efficiency in electricity use also, a lot of tips are available here. These are all taken from Bureau of Energy Efficiency site. Okay. You got efficiency motors in drives, pumps, in compressors. I think we teach this air compressors in fluid mechanics labs and all. We see, we study the efficiency of pumps and compressors. If you just see, again here variable speed drives are coming, VFDs, and lubricants also now, high quality synthetic lubricants are coming. Even for your bikes and cars, you got synthetic lubricants today. Then you have to change oil filter, lube oil properly. Then intercoolers you have to see. waste heat also, if it is there, you can use for some heating application. And you should have some proper maintenance program. Audits should be taken place. As I was telling about the DG sets, even air compressors also, it is saying that instead of having one centralized air compressor for the entire industry, they are now having small air compressors wherever it is required, so that the long transmission is avoided, because the transmission will be at high pressure, say 6 to 8 bar, and there will be losses if there are any leakage in the joints and all. That is why some small baby compressors are used wherever it is required near the load. And you might have seen earlier days people used to use this pneumatic guns, pneumatic wrenches and all. Now they have all been replaced with electrical, because we are we are using electricity to compress air, and then from compressing air we are using it in the equipment like wrenches. But now directly you are using electricity, so the efficiency is high. You can see in this garages and all, authorized service stations. Even DG sets, I think you are all having DG sets in your office, college, at least. Do you know what per liter of diesel, how much units of electricity the DG set should generate? Please write this. I'd like to know. You can make a guess. The DG, now you have got almost like, I have already given a hint in the form of SFC earlier, but one diesel is 1 per kg is almost 44,000 kilojoules. So what is how much electricity you can generate? Please write. You will understand then. Then vehicles, I think this will be very interesting for you. So you should drive at low speeds, optimal speeds, like that green zone is given in your car, bike, that green belt is there, some 45 to 60 kmph only. Then signal, if it is more than 15 seconds, you switch off the engine. Carpooling and tire pressure. I think now latest cars, they are coming with tire pressure indicators only. In the central console you can see that tire pressures. And proper driving habits of proper gear, engine tuning, all these things. I think you might be knowing all these things, just like to share. Clean the air filter, use brakes only when needed. See, I have seen all young people, basically they accelerate and then they brake also. See Baba, this both sudden acceleration and braking, they waste energy. And this here again you can see brake means the energy is converted into heat energy. So energy is lost in the form of heat. So this is not advisable. Go at a normal range. You anticipate and then use the brakes at the least possible, only when needed. Use clutch only to shift gears. Don't clutch means if you are keeping your foot on the clutch means it will disengage and wear out the liners. So that is, then the power loss will be there. Power transmission loss will be there. So lot of technologies are there. So buildings also we have discussed. I think we have discussed lot of things about building, walls, windows, painting, glasses, landscaping, HVAC. Then again miscellaneous things where you can see out. Like anything you want to monitor, basically. I told, I think we started with house. What is the electricity consumption or what are the energy sources. So once you write down, then once you measure, then only you can improve. If you look at this left side, you have got that motor generator set, the old technology, and on the right side you have got the rectifier set, DC. So these are the new technology. Like inverter is again the better technology for welding actually. So now coming to our institution, GSIT Karwar, actually when I took over, we saw that contract demand. I was telling contract demand. So just I would like to share that our contract demand was very high. We had taken high contract demand, but our actual maximum demand was low. So I studied for almost 2 years period at earlier data electricity bills we had taken, and we saw that our maximum demand was high and low, and contract demand was high, but we pay for the contract demand. Suppose our contract demand was 200 kVA and our actual maximum was 100 kVA. So we can reduce 100 kVA. So accordingly what we have done, 50% of the contract demand we have surrendered, and we are almost saving 25,000 rupees per month now, because per kVA they charge almost like 200 rupees per kVA. So it is more than 2 lakhs. This was earlier figure. It's more than 2 lakhs per annum. Secondly, we saw that main pump, which is delivering water to the entire campus with the hostel or building, that was a pump which was rewound 2-3 times without burning. So what we have done, we have bought a new energy efficient pump for around 21,000 rupees. But that also saves a lot of money. I have seen, I think every year it says almost 10,000. Means its payback period is less than 2 years. Just imagine. So these kind of simple things, na. And now we asked our students to study on this energy conservation. We are creating awareness under that AICTE activity points, na. Then students also have done KSST, like Karnataka State Council for Science and Technology sponsored projects on energy conservation in the college. And we do celebrate Energy Conservation Week. I think this December 14th was the Energy Conservation Day in India, celebrated last. And we also celebrate like Science Day, World Water Day, to bring awareness. Now coming to energy audits, we know all financial audits, like your college or organization, they have got financial audits. Similarly, there is something called energy audit. So energy audit is nothing but an inspection, survey and analysis of energy flows for identification of energy saving opportunities to reduce energy inputs without affecting the output. So basically here the main point is we want to find out the energy saving opportunities, but the output should not be affected. Okay, that is, these two things are important. Now let us look at what we require is we have to check, we have to measure and verify, compare with the benchmark, and we have to bring it in terms of money value. Like I told you about your house, you check how much electricity you are using, how much LPG, how much petrol, diesel you are using. Then you verify every month. Then you have a benchmark with others similar in similar conditions. Then you can convert into monthly expenditures or annual expenditure in terms of money. Because we are more interested in money rather than units of energy and all. Like nobody likes joules, watts. We are interested only in terms of money. So energy audits are undertaken in almost all the places, like industries, hotels. I told you designated consumers like steel, cement, fertilizer, cold storages, office buildings, residences, dairies, all these places. So there are mainly two types of energy audits. One is a preliminary audit or walkthrough audit. It's a short term audit for 2-3 days. It is not in detail. And second is a detailed energy audit. It's a long period where we study everything, like thermodynamically also we study, and we come out with lot of initiatives, and that is also called as investment grade audit. So there is a term benchmarking, what I use. Benchmarking means we compare with the standards. What are the standards? Like I told, in country itself, the energy intensity is high, 1.5 times of Asia and America. It means that we are consuming almost 50% more energy than what other countries are consuming. That is bad. So you should improve the technology. So that is the benchmarking when you compare with the standards. So now let us look at the instruments used. Mechanical, I like to just share mechanical instruments. Like one is flue gas analyzer, then draft gauge, infrared thermometers, anemometers to measure the air velocity, then ultrasonic flow meters, they are non-contact flow meters basically, then TDS, total dissolved solid meters, temperature indicators, emission measurements, then this CO2, CO, light, sound, RPM data loggers, they real time they log the data. Then you have humidity measurement, pressure measurement, and you have transmitters. Nowadays, earlier days we were all like having contact instrument. Now you have like non-contact instruments, and they are like Wi-Fi enabled, and real time they'll send the data on the cloud. So you need not be physically present to take the measurements. Remotely also you can take the measurements. So these are all the instruments we use. Then as I was discussing, for energy audits, the main areas will be like equipment, what you check to come out with the energy saving opportunities. What is the equipment oversize? Like for example, you take your own car. You have got 800cc car also, which takes people. Okay, 5 people it can carry. And you have also got 2000cc cars. Okay, but people now you just imagine, as a technical fellow, qualified person, which is more efficient to carry 100 kg person, one person of 100 kg. Even a bike will do. 100 kg bike can take one person, but we use big cars, and we are wasting, guzzling fuel, and this fuel has got not only economic consequences but environmental consequences also. So these are very dangerous things actually. So we should understand and appreciate that we are having a huge carbon footprint. We have also seen that 1% of the population is contributing so much. The top 1% is contributing so much, 35% of the emissions. Very bad it is. Then second is operating at full load. So part load you should not operate. Like I can give small example. If you have a cooker at home, so 5 kg cooker, and you are using, only 2 people are there, or one person is there and using 5 kg cooker, that is also waste. It is not using to the full capacity. You should have smaller capacity cooker, 2 liters, 3 liters cooker you can use. Similarly, star rating, go for higher star rating. These are initial cost is high. Definitely they are costlier in the initial cost. But if you look at the life cycle cost, please understand, if you look at the life cycle cost, they work out cheap. So it is always, don't look at, we Indians are mostly bothered about initial cost, but please look at the life cycle cost. Then use of renewable energy, I told you, you can have solar water heater, you can have solar photovoltaic system on your rooftop, that is good. And then industries also they can have waste heat recovery, wherever heat is being lost. See now your cars, you can see diesel cars, even petrol cars, now you got turbochargers. So whatever exhaust heat is going, that is used to drive the turbine in a turbocharger, so that you supply more air to the fuel combustion process. And maintenance of the equipment. See, one more thing what I have seen, maintenance is very important. Even lights, they are having a lot of dust. Nobody cleans the tube lights. That is bad. So if you don't clean the tube light, already 20-30% of light is lost because of that. So don't maintenance is also very important aspect. And we have seen the energy efficient technologies. I was telling boilers. Now instead of big boilers, you have got packaged boilers, small, based on your capacity. You can have. Then furnaces, also energy efficient furnaces with good insulation, good burners are there. Air conditioners are definitely inverter based air conditioners and DG sets you have got. Then air compressors. Of course, air compressors, earlier days you had only this reciprocating compressor, but today you have got this oiled screw type compressors. They are more energy efficient. LG, Atlas Copco, you got good manufacturers who make this screw air compressors. And waste heat recovery is of course is picking up, still a long way to go, but most of the units, industries which are sending out this heat now, they are trying to recover. So you can see the pictures of air compressor left top, this the screw air compressor. You can see the right side left top, top right, the screw compressor principally shown, the screws are there. Then you have got the furnace and boiler. Bottom right side you have got the boiler, packaged boiler. So very compact and packaged, clean boilers. And electrical technology, I think being mechanical engineers, we will see into this variable frequency drives. I got some graph onto that. Then power factory improvement, MD control, maximum demand controllers, energy efficient motors, dry type transformers, energy efficient welding set like inverter, then illumination. So you can see the star labeling actually. This is for diesel generator set. You can see the star rating. Now this is 3-star rated. So maximum it can be 5-star rated. So here you can see SFC, specific fuel consumption, is given as 252 grams per kilowatt hour, means per unit. Kilowatt hour is 1 unit. So 252 grams. So this is given as 3-star rating. Okay, now like this kind of label you will find in almost all the devices: motors, pumps, fridge, AC, everywhere, fans. And just to look at this star rating here, now we had seen here that is 252 grams per unit, that is 3-star. We can see here 1 star is almost 300 to 336 grams per unit. This is 1 star. Then 2 star is 272 to 302 grams. So as the star number increases, 1 star to 2 to 3, you can see there is a reduction. 5 star is less than 220 grams per unit. So almost you can generate nearly 4.5 units of electricity per liter of diesel. This was my point. And if it is 1 star, means it is only 3 units per liter of diesel. But here it is 4 to 4.5 liters. Sorry, 4.5 units per liter. So huge difference. See, please understand, we are consuming a lot of electricity at offices and colleges. So this makes a big difference. You can see here, it is given on the right side, I think 2.6 to 3.9 per liter. You can just imagine. So almost it is 1.5 times. So there is a procedure also to test this DG. I think there is a IS 10001 for less than 19 kilowatt, and even for alternators there is IS 4889. So these specifications we can teach our students. What are the specifications for engines, alternator, earthing, C3043, and how it is done. Like DG set is run at 100% loading for 15 minutes to reach the thermal stability, then reduced to 75% loading, 0.8 power factor, and all these fuel consumption other parameters are recorded for 4 hours at an interval of 30 minutes each. So the average of SFC of 4 hours will be considered for the test results. So it is not that we conduct like our lab experiments we conduct for 3 hours and everything is we take 5 readings and finish it off. It is not like that. Now for every 4 hours average we will take 1 reading. So in industry you can have fuel substitution. I can give one example for fuel substitution. The Parle-G factory is there in Hubli, LVT Industries. They were using electrical ovens were there for baking the biscuits. They have gone to natural gas now. So this is a case of fuel substitution. Or in your house you are using electric geyser, you switch to LPG or you switch to LPG, means it is fuel substitution. LPG is comparatively cheaper than electricity. Your car also, I think you have got petrol cars, then you put a LPG kits, that is fuel substitution. Similarly, energy generation, there is something called cogeneration. You might have seen sugar factories. They were only manufacturing sugar earlier, but today along with sugar they are manufacturing, means they are generating electricity. Okay, they are even generating alcohol. They are producing alcohol. So electrical generation along with power, heat or power, this is known as cogeneration. Then electricity distribution also, a lot of losses are there, around 20% on an average. So we should see what are the, when you want to give a suggestion, you have to see the technical and economical feasibility, space requirements, technology, manpower requirement, quality, safety. A lot of issues are in. You cannot just give one suggestion like I am giving right now, because it is all theoretical. And you go to the real floor and then you understand the situation, analyze it, and then give proper suggestions. Now coming to VFD, this is a very important technology. Very now like air conditioners, you have got all VFD, inverter AC, what you call. VFD is a type of motor controller that drives an electric motor by varying the frequency and voltage supplied to the electric motor. The other names of VFD are variable speed drive, adjustable speed drive, adjustable frequency drive, AC drive, micro drive, and inverter. See, what is speed of a motor? Synchronous speed ns is equal to 120 into f, that is frequency, divided by p. P is number of poles. 120 f by p. Number of poles is fixed. Only thing I can change is frequency. So by changing frequency, I can change the speed. Okay, and this is done by VFD. You can see VFD here. It is used in pumps also. Most of the, wherever motors are used, VFDs are used. Motors are used for lifts, for your AC, for fridge, everywhere, wherever motor is used, this VFD can be used. So like conveyor systems, blower speeds, pump speeds, motor tool speeds, lifts, ACs, they require various speed and variable torque. If you just see this graph, I think here you will get to know it in a very clear way. Like the top one is the real curve, red color. Okay, you have got two axes. X-axis is percentage capacity loading, and Y-axis is the power. Now please understand, you see this graph, all along I am telling you that you should go for full loading, not part loading. You can see that 100% loading, X-axis you can see capacity loading, the power requirement is 100. Okay, percentage power. Now you see here, this real curve is for 60% loading, the power consumed is 80%. Okay, so that is high. At that rate, just imagine 60% means loading means it should be 60% power, but it is not the case. For 60% loading, you can see the dotted red line. 60% loading, the power consumed is 80%. So this is not good. So for 60% loading, we want 60% power only should be used. So what? Now the blue line is the VFD line, variable frequency line, drive line. You can see here for 60% loading, the power consumed is 60% only. Okay, and now coming to 10% loading. Come to the extreme left on the y-axis, 10% loading. For 10% loading also, in a real life, you are consuming 50% of power. Is it acceptable? Even 20% you see. 30% capacity utilization, you are using 60% power. So that is why I told you should not go for part loading, you should go for full loading only. 30% capacity, you are having 60% power consumption. Red line, you please see red line, real curve. But you go to VFD, 30% capacity is consuming 40% power. And 10% is consuming only 25% power. You understood? So as the, especially 60% and below, when you see, you will find lot of remarkable difference. Okay. Even 80, below 80% only you can see the difference between the real power and the VFD drive power. So the VFD variable frequency drives, they consume less power even at part loads, right from 10%, 20, 30. So you can vary the power requirement. So this is why inverter AC and inverter lifts, they are very popular now because they use less power. Second is a power factor controller, like capacitors. What I told you, they are used to improve the power factor. Actually, this is in electrical term. Power factor is the ratio of active power to the apparent power, and it should be less than 1 in all inductive loads. Like wherever motors are used, you will have it less than 1. And for resistance loads like your electrical heater, AC, sorry, your iron box, water heater, it is 1. But wherever motors are used, the power factor will be less than 1. And because it is less than 1, we have to improve. And if it is less than 0.9 and all, the penalty is levied by the DISCOM. So we have got power factor control. This is automatic power factor controller. So this will improve the, you will find these installations near various machines in various industries. Then maximum demand controller. As I told, if you exceed the contract demand, whatever is there with the DISCOM is distributor company. Like in Hubli, you got Hubli Electricity Supply Company. Then in Mysore, you got Chamundeshwari Electrical Supply Company, BESCOM, Bangalore and all. So if you exceed the maximum demand, contract demand, whatever you are having, then you have to pay penalty. That is why people are using maximum demand controller, so that any it is exceeding the non-essential loads, that will be cut off. Automatically it will be cut off. So this is known as maximum demand controller, so that your demand of the industry or organization remains within the contract demand what you are having with the electrical supply company, that is DISCOM. And this is a national certification exam for certified energy managers and energy auditors. So these are the details. And lastly, these are the books, 4 books what I was talking. One is general aspect of energy management and energy audits. And second book is on thermal utilities. For mechanical engineers it will be very useful, energy efficiency. Third is for electrical utilities. And last one is the energy performance assessment of equipment and utility systems. So these all 4 books are available online, free, you can download, no issues. So the references I have taken from Bureau of Energy Efficiency, the guidebooks what I just discussed, then Central Electrical Authority, then MNRE, International Energy Agency, British Petroleum, Economic Times, United Nations Environment Program, as well as United Nations Emissions Gap Report. So be a responsible citizen, let us conserve energy. And any doubts are there, please ask me, or you can put in the comment box. Definitely I'll answer each and every question which is posed to me. I hope you enjoyed this learning, and hope to see you next. And let us all be responsible citizen and spread the message of conservation, environmental damage, and contribute our might. Thank you.